So pre-algebra, I'm not here today, so you'll need to do this lesson and pretend that I'm here. This is a big lesson, solving equations containing decimals, but we're also reviewing other ways we've done solving equations. If I had to think of the biggest skill that you need to take when you leave this class, it's solving equations, getting ready for Algebra 1. So just to review, if I see fractions in an equation, I can work with the fractions, but I also have a way of eliminating the fractions. So the least common denominator of 2 and 3 is going to be 6. So if I multiply everything by 6, all the fractions will go away. So every term gets multiplied by 6. The way I do that, 6 over 2 is going to be 3, so I get 3x equals 6 plus 2. Now I have an equation with no fractions. So I get what? 3x equals 8. Divide both sides by 3. And you get x equals 8/3. So here's an equation that started out with fractions. I solved it with no fractions. In my final step, there was a fraction in the answer. If I see parentheses with a variable expression, I need to distribute. So 2x minus 6 minus 1 equals 14. I can start adding 6 to both sides, adding 1 to both sides. Easier thing would be to combine like terms. 2x minus 7 equals 14. Now in order to get everything with an x on one side, everything without an x on the other, just one step. Add 7 to both sides. So 2x equals 21. Divide by 2. X is 21 over 2, which is what? 10 and 1/2. Again, when I see multiple terms that can be combined on one side, I make things more efficient if I combine like terms. Nothing can be combined here on the left. On the right, 5x plus x is 6x, so 6x minus 7. Now, to gather everything with an x on one side, I can subtract 2x from both sides. 1 equals 4x minus 7. Now I can add 7 to both sides. 8 equals 4x. Therefore, x equals 2. The other thing is the addition property. That's probably one of the things we use the most, is adding the same thing to both sides. So I always, when I see an x and a constant, I always try to take care of the x term first. If I subtract 2x from both sides, I get 4 equals x minus 5. The only thing left to do would be to add 5 to both sides. So 9 equals x. And if you see something that has a coefficient that's multiplied, you solve for x just by dividing by that coefficient. So x equals 8/5. Now let's look at this one. So there's nothing new here. I've just got a decimal number involved. I still have the same goal, getting everything with an x on one side, everything without an x on the other. I can do this by adding 1.5 to both sides, and that just gives me x equals 9.5. And the next one, to get y by itself, you divide by -2. I know this is going to be a negative number. Okay, so I just need to figure out, how do I divide 2 into 6.7? 2 goes into 6 3 times. So 2 goes into 7 3 times. That's 6 with a remainder of 1. 2 goes into 10 5 times. So -3.35 is y. Similar here, I need to get everything with an x by itself. In order to do that, I'm going to have to subtract 5.8 from both sides. So 1.2x equals, so 12 minus 8 is 4, 7 minus 5 is 2. This answer is 2.4. So then divide both sides by 1.2, and then x is equal to 2. Here I've got x's and constants. If I subtract 4x from both sides, that leaves me with what? 3x plus 3.2 equals negative 1.6. Subtract 3.2 from both sides. So 3x equals, that's going to be what? Negative 4.8. So x is negative 4.8 over 3. This is a negative number. So 3 goes into 48, what, 16? 3 times 16, and with 1 decimal point, so negative 1.6. When I see this, same thing, I'm going to need to distribute. So 5x, and then 5 times 0.36. So 5 times 0.36. 5 times 6 is 30. So that's going to be 180, and 2 decimal points, 1.8. So 5x minus 1.8 equals negative x plus 2.4. If I add x to both sides, I get what? 6x minus 1.8 equals 2.4. Add 1.8 to both sides. So 6x equals, that's a 2, 4.2. Then x is going to be equal to 4.2 over 6. 6 goes into 42, as you know, 7 times. But there's 1 decimal place, so 0.7. Now, why do we teach people to multiply by the common denominator when I have fractions? Okay, mainly because I eliminate the fractions. So the common denominator here is going to be 12. So if I multiply everything by 12, 12 times 1/2 x plus 12 times 1/4 equals 12 times 1/3 x minus 12 times 1/2. Some people like to skip writing all that down and do it in their head, which is okay as long as you're not making mistakes. But if I write everything down, I'm forced to do each piece. So 12 over 2, that is 6x. 12 over 4 is 3. 12 over 3 is 4x minus 6. Now I've got an equation that has no fractions. So fairly straightforward. Subtract 4x from both sides. So this gives me what? 2x plus 3 equals negative 6. Subtract 3 from both sides. 2x equals negative 9. So x equals negative 9/2. Answer was a fraction, but I did not have to work with fractions after I eliminated them until the final step. Now, what would happen if we did not do that? You're welcome to try this, but you should see it's probably a little bit more work. So I've got 1/2 x plus 1/4 equals 1/3 x minus 1/2. So I can subtract 1/3 x from both sides. Now I need to know, what is 1/2 minus 1/3? The common denominator is 6. So this gives me what? 3/6 minus 2/6 equals 1/6. So I get 1/6 x plus 1/4 equals minus 1/2. Now I can subtract 1/4 from both sides. So I need to figure out negative 1/2 minus 1/4. Basically, I add them and keep the negative sign. The common denominator there is going to be 4. So this is negative 2/4 minus 1/4 is negative 3/4. Now I'm going to divide both sides by 1/6. So this is negative 3/4 times the reciprocal, 6 over 1. This is negative 18 over 4, or negative 9/2. Now it should be clear to you why we like to multiply up front by the common denominator. it's a lot easier to work with the integer coefficients than the fractional coefficients, okay? Same thing can be done with decimals. So if I look at this, what could I do to make the decimals go away? So if I take the one that has the most decimal places, if I multiply that by 100, I would have no decimals. So I could multiply both sides of this equation by 100. So it would be 100 times 0.5y plus 100 times 2.3 equals 100 times 1.65. So the decimal moves 2 places. So you get 50y plus 230 equals 165. Subtract 230 from both sides. So you get 50y equals and 6. That right? So negative 65. So 10 minus 5 is 5. 12 minus, yeah, so it's negative 65. So y is equal to negative 65 over 50. Divide those by 5. Negative 13 over 10. Now, alternately, you could just keep the decimals in the problem. I could subtract 2.3 from both sides and then do decimal division, okay? Now, one of the big skills coming out of this is think of the ways we can solve this particular problem. I'm going to show you 4 ways to solve this problem, and I want you to study these and study what the words are, because we've talked about all of these ways, and I would rather you have 4 ways to solve a problem than only 1 way to solve 4 different problems. So you're more flexible if you've got more choices. So I want to solve the equation with the decimals in place, not eliminating decimals. So let's just work with decimals. So you're going to have 2.4x minus 1 equals 4x. So I'm going to distribute 2.4x minus 2.4 equals 4x. I'm going to subtract 2.4x from both sides. So I get negative 2.4 equals, so that's going to be 1.6x. Now I find that if I divide by 1.6, so I need to do that division, 1.6, divide that into 2.4, answer is negative, move the decimal place right there, okay. 16 goes into 24 1 time, that leaves me an 8, bring down the 0, 16 goes into 8 15 times. So in this particular case, did I do that right? When I moved the decimal one, I forgot to write the decimal down. I moved it 1 place, not 2 places. So 1.5 is negative 1.5. So x equals negative 1.5. Now, to solve by eliminating decimals, I could eliminate the decimal if I multiplied that by 10. So 10 times 2.4 times x minus 1 equals 10 times 4x. So 10 times 2.4, this is 24. X minus 1 equals 40x. So 24x minus 24 equals 40x. Subtract 24x from both sides. So negative 24 equals 16x. So x is equal to negative 24 over 16. I can divide those by 8. Negative 3 halves. which is the same answer there. So I know it's right. Okay. Now let's convert this to an equation with all fractions and work with fractions for the entire problem. So that 2.4 is 2 4/10. So 2.4 is what, 2 4/10, or 2 2/5, or what, 12/5. So 12/5 x minus 1 equals 4x. Is that right? So if I distribute 12/5 x minus 12/5 equals 4x, okay. So I'm going to subtract 12/5 x from both sides. So negative 12/5. So 4 minus 12/5. Common denominator is 5. So 4 times 5. So 20 over 5 minus 12 over 5 is going to give me 8 over 5. So 8 over 5x. I'm going to divide both sides by 8/5. Dividing by 8/5 is multiplying by 5/8. So it's going to be negative 12/5 times 5/8, which is negative 12 over 8, negative 6 over 4, negative 3 over 2. I know that's the right answer. Okay. Now, I can do the same problem, but instead of working with fractions, I'm going to eliminate the fractions. So 12/5 times x minus 1 equals 4x. So to eliminate the fractions, I'm going to multiply by 5 on both sides of this equation. So I get 12 x minus 1 equals 20x. 12x minus 12 equals 20x. Subtract 12x. So negative 12 equals 8x. So x is negative 12 over 8. Divide those by 4 and you get negative 3/2. So here, this is one of the big moments in this class this semester. It doesn't feel like it, but what I pulled together is we have solved equations just with working with decimals. We can eliminate decimals, we can work with fractions, or we can eliminate fractions. So understand that you can work problems all those different ways. Convert this to an equation with all fractions instead of decimals. So I need to convert everything that I see as a repeat to a fraction. So if you've forgotten how to do that, let's take x equals 0.66 repeat, which is, that's really just x equal 0.6 repeat. So 10x equals 6.6 repeat. Subtract and you get 9x equals 6. X equals 6/9 or 2/3. So this is 2/3 x minus 1 equals, okay, 0.4 is going to be 4/9 x plus 2 minus 2.2 repeat. It's going to be 2 2/9, which is what, 20 over 9. Now I'm going to work this problem two ways. Work it with the fractions or work it by eliminating the fractions. So if I work it with the fractions, I'm going to get what? Distribute 2/3 x minus 2/3 equals 4/9 x plus 2 times 4/9 is 8/9 minus 20/9. So on the right, I can combine 8 minus 20, that's negative 12. So I get 2/3 x minus 2/3 equals 4/9 x minus 12/9. So I can subtract 4/9 x from both sides. So I need to know what is 2/3 minus 4/9. So multiply this guy by 3. So 6/9 minus 4/9 is 2/9. So I get 2/9 x minus 2/3 equals negative 12/9. Now I need to add 2/3 to both sides. So what is negative 12/9? If I divide those by 3, this is what, negative 4/9? So, negative 4/3. Negative 4/3. So I've got negative 4/3 plus 2/3 is negative 2/3. So 2/9 x equals negative 2/3. Divide by 2/9. So my answer is negative 2/3 times 9/2, which is negative 9/3, which is negative 3. Okay, that's a lot of work with fractions. Let's take the same problem and eliminate the fractions, which I think you will like better. So write down this problem. I'll get a little bit lazy. I'll just copy it down. So take that problem and let's work it. Okay. So the common denominator is 9. So I'm going to multiply 9 times 2/3 x minus 1 equals 9 times 4/9 x plus 2 minus 9 times 20/9. That simplifies things quite a bit because 9/3 is 3. So this becomes 6 x minus 1. The 9's go away. 4 x plus 2 minus 20. Okay, I like this equation a lot better because there are no fractions. So distribute 6x minus 6 equals 4x plus 8 minus 20. So 6x minus 6 equals 4x minus 12. Subtract 4x. So 2x minus 6 equals negative 12. Add 6 to both sides. 2x equals minus 6. X equals negative 3. And I get the same answer. Okay? That leads us up into the homework for this particular section. Okay?